our Math 158 test, preview, review, and this will be part 2. Part 1 was the video just titled December 1st, and this one is obviously going to be December 12th, or sorry, December 6th, and your test is on the 8th. So where did we leave off? We left off talking about logarithms. We had our exponential equation, which could be written as a log equation. Think of this as your Rosetta Stone, if you will. And this allowed you to translate exponential forms to log forms, typical problems. We looked at a bunch of those in class, and we had a bunch on here, but just one of each. If I had log base 4 of 64 is 3, this would translate to 3 to the 4th, sorry, 4 to the 3rd. The base is the number on the bottom here, right? Base is on the bottom. So 4. And the logarithm itself, this number by itself, is the exponent. Okay, and sure enough, you check that, 4 cubed is 64. Okay, so that's a log going to exponential. If I gave you an exponential, 8 to the negative 2/3 power is 1/4, and hopefully you could verify that if you wanted to, but let's just translate it. Log, the base is 8. The logarithm itself is the exponent, so that's negative 2/3, and the argument here is 1/4. So these say the same thing, and it's probably not a bad idea just to go ahead and do a quick review of negative exponents. 8 to the negative 2/3 is the same as 1 over 8 to the 2/3, and you notice the root right here. The root is on the bottom. So this is a cube root of 8 squared, or if you want, 1 over cube root of 8 is 2, 1 over 2 squared is 1/4. Okay, and that's what that says. Okay. A couple of other things about this idea. If I gave you a log equation, actually here's a log equation, log base 3 of 81, and I said, what is x? What number is x? You go, well, geez, I don't know how to do that. But you do know log base 10 of 100 is 2, and that translates this way. 10 squared is 100. So let's just rewrite this one, sort of the same idea. We have the base, which is 3. The exponent, which we don't know, is the logarithm, that's x, and the argument's 81. So again, you can sort of play 100 is the argument, 100 is the value, 81 is the argument, 81 is the value. The base, right, the base, small number below the log is 10, the base is 3, that translates to the base of the exponential, the base of the exponential. And the logarithm itself, this 2, in this case it's x, 2 and x. Okay, so hopefully that helps a little bit. But now, what number is x? So you look at this and you go, geez, I guess I'm supposed to know that. Well, 3 to the 0 is 1, 3 squared, or how about 3 to the 1st, Joe? 3 to the 1st is equal to 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. So x has got to be 81, or x has got to be 4. Okay. So in this case, x is 4. X is 4. This idea of this exponential growth is related to the log graph. So again, let's take a quick look at the exponential. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, I'm going to have to sort of break my scale here a little bit. Some of the points we had were 0, 1. We had 1 and 3. We had 2 and 9, 3, 4, 5, 6, 7, 8, 9. So that's right about here. This is 2 and 9. 3 and 27, so way up here somewhere. So imagine there's a point up here, 327. And way up would be the point 481. So this does rise very rapidly. Yes, it's invertible. Yes, we can rewrite this. This is y is 3 to the x power. And if we just translate that, let's see, how to find the inverse. Remember we had this recipe. Well, let me do it this way. Here's our function in black. F of x is 3 to the x. The recipe was replace f with y, and then go ahead and swap the x and the y. X is 3 to the y, and then go ahead and solve for y. And now you're wondering, how might you solve for y? Well, basically we want to get this y by itself, and that's the exponent. So we know how to do that. We have a translation key. Once again, I'll go back to, 10 squared is 100, and log base 10 of 100 is 2. So if I just take this red equation, x is 3 to the y. We're trying to get the y by itself. So we're going to write log base 3 of x equals y. Okay. So this black curve actually has an inverse curve. All these points would be changed, right? So that this point 0, 1 turns into an inverse point 1, 0. This point 1, 3 turns into 3, 1. The point 2, 9 turns into 9, 2, 3, 4, 5, 6, 7, 8, 9, 2. Like right about here, 9, 2. The point that was way up there, 327 would be way over here somewhere, 27, 3. So you could imagine 9, 10, 11, 12, 13, 14, 15. Okay, so somewhere out here, there's another point that I can label 27, 3, 27, 3. And the log curve looks like this. Okay. So it's the inverse, it's the mirror image of the exponential curve. Okay. So if I wanted to use my little function notation, f inverse is log base 3 of x. Okay, that's the inverse. This was the original, the exponential growth curve. Now, smartboard's sort of frozen here. Let me see if I can stop that. Okie dokie. There we go. Okay, last thing I wanted to talk about briefly was what happens if you had some equations like this. Now this is just sort of a generic log equation. Log base x of x is 1. So that looks a little strange. Let's put a number in there. Log base 10 of 10 is 1. Log base 3 of 3 is 1. And if we translate these, again, just use your Rosetta Stone, you would see this says 10 to the first is 10, or 3 to the first is 3. So that sort of makes sense. Log base x of x is 1. But we do have some restrictions on x. Whenever we're talking logarithms, the base must be positive. Base must be bigger than 0. You'll never allow to have a negative base. This would be illegal if you had the log of -2, base -2. Okay, so we're not allowed to do that. Base must be bigger than 0. And the other thing that we somehow delete, we do not want the base to be 1. We don't consider that an exponential function. Okay, so if looking at a problem like this and ask what are the restrictions on x, You simply have to say x is bigger than 0, but not 1. Okay, let's look at a typical example of this. Suppose you had log base, I don't know, a number bigger than 1. How about pi? Pi, log base pi of pi is equal to 1. Okay, so if we translate that, here's our translation key again. Log base 10 of 100 is 2. 10 squared is 100. Okay, so we remember that. And then we just translate this. Pi is the base. The exponent is 1. And we get pi. Okay, so that makes sense. I have that. No problem. Suppose I, instead of having pi, I had pi cubed. Ooh. Now the question is, what would this be? Now let's do two different colors here. I'll do the question marks in red. And the exponent of pi is 3. You say, well, I'm not sure how to do that, but let's translate it and see what happens. Okay, so the base down here is pi. The exponent is the logarithm, right? This 2. That's the same as the exponent. So we don't know what that is. We'll put the question marks there. Okay, and then the argument, this 100, that's the value of the exponential. So we'll put that on the other side, and that's pi cubed. Now, if you just look at that equation and say, what does the question mark have to be? Well, I think it's pretty clear. The question mark has to be 3. So if I ask you to, quote, solve this equation, tell me what x is, you would say, well, x has to be 3. X has to be 3. It's just a sort of a generalization. If we had the 1 here, then that worked out to be 1. If we had a 2 there, this would be 2. If we had a 3 there, a 3. Okay? So, yep, another type of problem you might encounter on Tuesday. Okay. That's about it. Exponentials, logs, and a little bit on the quadratic formula, a little bit on invertible functions, domains of radical functions. This should be a nice, simple test. After the test, I'll give you some sample questions for the exam that you can look at. You should have, and also give you, by the way, when you hand in your test, I will give you the solution to that. So you can take that home and go, yep, got it, yep, I got it, yep, I got it. But more importantly, you'll be able to look at those questions and study them for the exam. Again, after the test, a little bit of review for the exam. And then the exam is going to be a week from Tuesday. Okay? See you Tuesday night.